Hi everyone, today we will discuss Laplace transform of f of t, that is for f of t is equals to 2t if 0 is less than or equal to t is less than 1, t if t is greater than 1. So we will find out Laplace transform of f of t and Laplace transform of f dash of t. For this, we'll first write the frame, that is Laplace transform of f of t is equals to integral over 0 to infinity e power minus pt into f of t dt. This is the frame of Laplace transform, and which is equals to integral over 0 to infinity e power minus pt into f of t dt. So now f of t value will take two different values, right? For 0 to 1 and t for greater than 1. So we'll divide this whole integral into 0 to 1 and 1 to infinity. So f of t will take 2t for 0 to 1, and from 1 to infinity it will take the value t. So integral over 0 to 1 e power minus pt into 2t dt plus integral over 1 to infinity e power minus pt into t into dt. So integrating 2 into integral over 0 to infinity, again Eilert rule, the first function into second function. So first function into integral of second function minus integral over 0 to 1 derivative of first function, that is t is 1 into integral of second function e power minus pt divided by minus p dt, plus again we are integrating this. So that is first function into integral of second function minus integral over derivative of first function into integral of second function. So as you can see, the limits are from 1 to infinity. If you substitute the values, substitute the limits, that is for this, if you integrate and substitute the limits from 0 to 1, since it is 0, t value is 0, right? So it will become 0. Since t is equals to 1, it will become 1. So e power, since it is in upper limit, it will be changed to e power minus pt divided by minus p. So only one term will be remained, minus integral over 0 to 1 e power minus pt divided by minus p dt. Integrating it again, will get e power minus pt divided by p square under the limits 0 to 1. So instead of t, if you substitute the limits, you will get e power minus p minus of e power 0, that is 1, divided by p square, then plus e power minus p divided by p for this, that is e power minus p divided by p. So this is for the second limit. If you substitute infinity over here, this term will vanish, that is e power minus infinity will be 0. If you substitute 1 over here, you will get e power minus p divided by minus of minus 1 by p, that is e power minus p divided by p minus, if you integrate this, you will get e power minus pt divided by p square under the limits 1 to infinity. So if you substitute the limit infinity, this will go to 0. Substitute 1, it will change to e power minus p divided by p square, minus of minus plus 1. After that, this was the first term, this was the second term. When you substitute 0 and 1 limits, you will get the value of this. So now compare and check out the common terms, that is e power minus p divided by minus p, 2 into e power minus p divided by minus p plus e power minus p divided by p, that is e power minus p divided by minus p, minus of e power minus p divided by p square, 2 into e power minus p divided by p square, so minus 2 plus 1. So we'll get minus 1 into e power minus p divided by p square, minus of minus plus 1, 1 into 2, 2 divided by p square. So then f dash of t. F dash of t will be, for 0 to 1 it will be 2, since 2t ka derivative is 2. For t greater than 1 it will be 1, since t's derivative is 1. So now Laplace transform of f dash of t, which is equals to integral over 0 to 1 2 into e power minus pt dt plus integral of 1 to infinity e power minus pt dt. So there is no other term, only e power minus pt. So just simply integrating it and substituting the limits 0 to 1, that is will get, yeah, so when we substitute the limit 0 to 1, we'll get e power minus p minus 1 divided by minus p, and on integrating it we'll get e power minus pt divided by minus p, and the limits from 1 to infinity, if you substitute infinity it will go to 0, and if you substitute 1 it will go to e power minus p minus of e power minus p divided by minus p. Minus minus gets cancelled, we'll get plus over here. So here is equals to 2 into e power minus p minus 1 divided by minus p. So 2 into e power minus p divided by minus p minus e power minus p divided by minus p, which is equals to e power minus p by minus p, that is e power minus p by minus p plus of minus. So plus 2 into minus 1 is minus 2 divided by minus p. So we will be remained with Laplace transform of f dash of t is equals to e power minus of e power minus p divided by p plus 2 by p. So in this way we can find the Laplace transform of f of t, whose value is 2t if 0 is less than or equal to t is less than 1, whose value is t if t is greater than 1. Thank you so much for watching. If any doubts, please do comment.